Hey there, this is Dr. Rishi from the Learners Academy, and today we are going to take one more step towards learning trigonometry. In my last video, we discussed about the basics of trigonometric ratios, what the trigonometric ratios are, and how we can define them. Today we are going to see how we use these trigonometric ratios to find different sides of a triangle. Before we go ahead, let us take a revision to what we did in the previous class. In the previous class, we talked about a right angle triangle ABC having a right angle at B and this angle being theta. From there, we defined 6 trigonometric ratios, namely sine theta, cos theta, tan theta, cot theta, sec theta, and cosec theta. Now let us see what we can do with this knowledge. Suppose we have a triangle ABC and one of the sides is given to us and one of the trigonometric ratios is given to us. Then we can pretty much use it to find the remaining sides of the triangle. This is one of the most useful things about trigonometry because this has a lot of practical applications in real life. So let us consider a very simple example. If we have a triangle ABC and if suppose my angle if suppose my side AC is 5 centimeters and my sine theta is 3/5, then how can I find the remaining sides? So the problem is very simple. I am given sine theta, it is equal to 3/5 and one of the sides is 5 centimeters. That is, the hypotenuse is 5 centimeters. So this is what we are going to do. Since we are dealing with ratios, we would take a common multiple. We'll say that let the common multiple be k. Then since I know that sine theta is equal to the opposite side upon hypotenuse, I can modify this particular triangle and say that my AC is 5k and my BC is 3k. Then it would make my sine theta as 3k/5k. So I can go ahead and I can find the values of all the 3 sides that are there. The other piece of information that I had was AC is equal to 5 centimeters. Therefore, 5k is equal to 5 centimeters or k is equal to 1 centimeter, meaning the common multiple is equal to 1 centimeter. This would give me the lengths of the remaining 2 sides that are there. So I can say AB is equal to 4 centimeters and BC is equal to 3 centimeters. This is how I can use one trigonometric ratio and one side of the triangle to find the remaining 2 sides. I can also go ahead and find the remaining 6 ratios from the information that I have just obtained. Now, since we have seen that AB is equal to 4 centimeters, I'll make the changes here. AB is 4 centimeters, BC is 3 centimeters, and AC is 5 centimeters. Using this data, I can easily find the remaining 5 trigonometric ratios. So let's go ahead and find those trigonometric ratios. So by definition, cos theta will be equal to AB upon AC. So it would be 4 upon 5. Tan theta will be equal to, we can either say sin theta upon cos theta, or we can say BC upon AB. So that would be equal to 3 by 4. My cot theta will be equal to AB upon BC. So it will be equal to 4 by 3. Further, sec theta will be equal to AC upon AB. So that would be equal to 5 by 4, and cosec theta, which will be equal to AC upon BC. So that would be equal to 5 by 3. Let us consider an example that is solved in class 10th CBSE. Many of my students, when we do this particular example, find it slightly difficult to get the explanation. That is the reason why I am explaining it here. So let us consider this example. If angle B and Q are acute angles such that sin B is equal to sin Q, then prove that angle B is equal to angle Q. This example is slightly complicated because it uses two concepts. One which we have taught just now, that is trigonometry, and another concept, that is similarity, which we had done in the previous video. And this is the reason why some of the students get confused in proving this particular. So in this particular example, there are two triangles, triangle ACB and triangle PRQ, and sin B is equal to sin Q. This is the data that is given to us. So let us see how we will be going ahead with this. Let us consider two right angle triangles, triangle ACB and triangle PRQ. The right angle is at angle C and angle R respectively. Now, according to the given condition, sin B is equal to sin Q. Now, if you look at the figure, the value of sin B will be AC upon AB, and sin Q will be PR upon PQ. Now, since these two values are equal, we can say that therefore AC upon AB is equal to PR upon PQ. Therefore, I can say that if I take this AB on the other side of equal to, it would come on the numerator side, and if I take this PR on this side, it would come on the denominator side. So I can say AC upon PR is equal to AB upon PQ. And I would consider this ratio as equal to K. Now, why am I going to do this? Because I want to define one side of the first triangle as a multiple of the second side. Now, we are going to do it so that we can cancel them out in the later part. You'll see how we are going to do it. From this, we can say that AC is equal to K times PR and AB is equal to K times PQ. Now, What can we say after this? If we look at the triangles, then we can say that AC square plus BC square is equal to AB square by Pythagoras theorem, and also PR square plus RQ square is equal to PQ square. Or we can say that, so if now since we already have two sides that are in equal ratio, if you are able to prove that the third side is also equal in ratio, we would be able to prove that these two triangles are similar, and if they are similar, their angles are going to be equal. So we have to prove that the third side is also in equal proportion. So we've taken care of AC and AB. The third side that we are looking for is BC. So effectively the reason why we are doing this is to prove that the ratio of BC upon QR should be equal to K. This would prove that all the three sides are in proportion, and we can say that they are similar by SSS test of similarity. So let's take it to the next level. We have to prove that the ratio of BC and RQ are equal. So let us see how we can do it. So I can say, let's first go ahead with proving what AC is equal to, what BC is equal to. So I can say that BC square is equal to AB square minus AC square, or BC is equal to root of AB square minus AC square, and RQ square is equal to PQ square minus PR square, or RQ is equal to root of PQ square minus PR square. Now let's take the ratio of BC upon RQ. So BC upon RQ can be written as root of AB square minus AC square divided by root of PQ square minus PR square. However, this AC is K times PR and AB is K times PQ. So AB square will be equal to K square times PQ square minus AC square will be equal to K square times PR square. The whole thing divided by PQ square minus PR square. If we go ahead, since K is common in both of them, we can take it outside and write a root of K square multiplied by PQ square minus PR square divided by PQ square minus PR square. Now this K can be taken outside the root and it would give me K times a root of PQ square minus PR square divided by root of PQ square minus PR square, giving me the final answer as K. So we have ended up proving that BC upon RQ is also equal to K. This means that AC upon PR is equal to AB upon PQ is equal to BC upon RQ is equal to K. Since we are able to prove that these three sides are in equal proportion, we can say that the two triangles are similar by SSS test of similarity, and if two triangles are similar, then their angles are equal. So this will imply that triangle ABC is similar to triangle PQR, and therefore angle B is equal to angle Q. Now this was an example from standard 10th CBSE. The chapter was trigonometry. Now let us go ahead and talk about one more example, which is a frequently asked doubt when I do physical classes. This is from standard 9th ICSE chapter 22 trigonometric ratios. We are talking about example number 5, which is one of the initial examples that are there. However, many of my students found it difficult to solve at the first go. So let us have a look at this particular doubt. For the given figure, if cos alpha is 5 by 13 and cos beta is 3 by 5, then find the length of BD. Now, so what is given here is we have two triangles, triangle ABC and triangle CDE. They are right angle at B and C, and AB is 12 centimeters, ED is 8 centimeters, and we have to find the value of BD. Now it looks slightly tricky because there are two triangles that we have to deal with. However, it becomes a lot easier if you deal with the triangles separately. So if let me first deal with the first triangle, that is triangle ABC. So I will draw triangle ABC separately. In triangle ABC, I have angle alpha here, and this is 12 centimeters. This is 12 meters, and I have angle A, B, and C. Now, so I have cos alpha is equal to 5 by 13. So I can say that I can take a common multiple x for the remaining two sides, and I can say that now cos alpha in this case is BC upon AC. So let me take a common multiple for both of them. So I take common multiple as x, and I say AC is, so AC can be written as 13x and BC can be written as 5x. So from the figure I can easily say that AC square is equal to AB square plus BC square. Since the value of AB is given, what I will try to do in this scenario is I will try to keep the value of AB on one side and everything else on the other, because the other parts, that is AC and BC, have a variable x in them. So I can write AC square minus BC square is equal to AB square, giving me 13x square minus 5x square is equal to 12 square, or 169x square minus 25x square is equal to 144, or further I can get 144x square is equal to 144, or x square is equal to 144 upon 144, so that's equal to 1. Therefore, the value of x would be equal to 1. In reality, whenever we square root a number, the value should be plus as well as minus. However, we would not be considering the negative value in this scenario because we are talking about the lengths, and lengths obviously can't be negative. So we can go ahead and we can find the value of AC. So AC is equal to 13x, so that would be equal to 13 meters, and BC is equal to 5x, so that would be equal to 5 meters. I will write these two values up here and then we can go ahead and find the value of CD. Now, for the second part, we will be using the second triangle, that is CDE. So I have my triangle CDE like this. ED is 8 meters and angle C is considered as beta. So they've given us cos beta is equal to 3 upon 5. Now cos beta in this case is CD upon CE. CD upon CE. Here cos B is given as 3 upon 5. We also know that cos B is equal to CD upon CE. Since this is a ratio, let us take another common multiple. We'll call it as y. So I can say CE is equal to 5y and CD is equal to 3y. Then we apply Pythagoras theorem one more time, giving us CD square plus DE square is equal to CE square. However, CD and CE have a variable y in them and ED is a number. So I would try to keep ED on one side and CE and CD on the other, giving me CE square minus CD square is equal to DE square. CE square is 5y square minus 3y square is equal to 8 square. So this would be 25y square minus 9y square is equal to 64, or 16y square is equal to 64, or y square is equal to 64 by 16, so that is 4. Therefore, I can write y is equal to 2, that is root of 4. Now, this gives me the value of CE. So CE is equal to 2 times y. CE is equal to 5 times 2, so 5y. CE is equal to 5y, so that would be equal to 5 multiplied by 2, so that is 10, and CD is equal to 3y, so that would be 3 multiplied by 2, so that is 6. So effectively BC is 5 meters and CD is 6 meters. Therefore, since now there's one more thing that is there, that since B, C and D are collinear, BD will be equal to BC plus CD, so that is 5 plus 6, so that is 11 meters. And this is how we arrive to the final answer for finding BD. That was it from my side today. Today we discussed the use of trigonometric ratios in finding lengths of sides, using two examples, one from CBSE, one from ICSE. In case you have any queries, feel free to comment your queries so that I can help you to solve them. This was Dr. Rishi from the Learners Academy. Stay tuned for more maths. Thank you.